Now we are going to start with another property of liquid, that is the viscosity. You must have seen that different liquids are like, as we know that liquids also fall in the category of fluids. That means they flow, they have a tendency to flow. But what we observe in case of liquids, that there are certain liquids which readily flow and there are certain liquids which flow, but the speed with which they flow is very less. So that means we can say that some liquid flows with the higher speed, or you can say they flow rapidly, and there are certain liquid they flow very slow. Now when the liquids which actually flow at a slow rate, that means in them that within molecules intermolecular force of attraction is high in them. The molecules which you can say the liquids which flow at slow rate, that means they are not allowing themselves to get separated. So we can say they have strong force of attraction between them, and that is the reason we can say that they are highly viscous. That means they have a tendency to cling with each other. So we can say they are highly viscous. But when we see these other liquids that I told you which flow rapidly means that they do not have a tendency to cling with each other because their intermolecular force is somehow less, and therefore we can say that they are less viscous. They are less viscous. So that means the liquid which have a tendency to flow rapidly, that means you can say that they have less resistance between them. Or you can say less resistance is offered because the force of attraction is weak, so they are less viscous. But when we talk about the liquids which flow at slower rate, that means they are not ready to get separated as their intermolecular force is high and the resistance offered in the flowing, when they are flowing is comparatively high, therefore they are highly viscous. So we can say that what is viscosity actually? Viscosity is the internal resistance to the flow of liquid. That means there is a certain kind of obstruction which is within the substance, that it does not allow substance to flow. That means the resistance which is offered to the flow of the liquid is called as viscosity. So as I told you that some liquids have lower resistance, some has higher resistance. The one which have lower resistance is that means they flow rapidly. Rapidly means they have less force of attraction, and as a result they are less viscous. But the one which flow at slow rate, that means they have high resistance because intermolecular force is high and they are highly viscous. So this is what is a viscosity. Now if we try to explain that what is the reason that they are in like you can say the resistance, what is the cause of the internal resistance within the liquid. So actually we can explain by considering the liquid. So we say that the liquid which is present in a tube or a vessel or anything consists of thin cylindrical coaxial layers like this. It actually consists of layers. So like if I say that this is my tube, so there are layers like this, right. So we say that the layer which is close to the tube, the wall, you can say the layer which is close to the wall, it is almost stationary. It is almost stationary. So that is why it has less velocity. So it flows at slower rate. So if we say that if we start moving towards the center, so this is not closer to this wall, so comparatively its velocity is high and it has a tendency to flow rapid as compared to this first layer. Then we move to another layer, so this has more velocity than it because there is less force of attraction between the wall and this, and therefore we can say that it has a higher velocity, so it will flows with a higher speed. So like this we see that as we move from tube to the center, we see that velocity goes on increasing. That means tendency to flow increase. That resistance is decreasing and tendency to flow is increases. So this is what we are trying to explain here. That liquid is actually made up of thin cylindrical coaxial layers. The layer which is in contact with the wall of tube is almost stationary. As we move from the wall to the center, velocity keep on increases and it becomes maximum in the center. So that means we see a kind of you can say trend in the velocity, that as we move from center to wall, velocity keeps on decreasing, or we say that when we start moving from the wall of the tube towards the center, velocity goes on increasing. So due to this difference in the velocity, therefore the flow is actually different, and you can say that this kind of flow is called as laminar flow. Because here you can see that there are different laminas, and when we pour a liquid, so the layers are flowing, but they are flowing in a layers. That is called as laminar flow. The center layer is flowing fast, and as we move towards the tube, the speed of the layer actually decrease. So we can actually also say that, like suppose if I pour a liquid here, so that means this layer is not allowing this layer to flow. So that means it is somehow offering a resistance to this layer. Likewise, this layer will not allow this layer to flow. So that means this is offering a resistance to this. So that means one part of liquid is offering one lamina, you can say, is offering a resistance to the another layer. So that means it is not allowing the other layer also to flow. So this kind of friction that offered by one part of liquid to the another part can also be called as viscosity. Can also be called as viscosity. So we have two definitions for viscosity: internal resistance to the flow of liquid, or force of friction, offered by one part of liquid to the another part, is also called as the viscosity, and the reason is that due to the laminar flow, and you know that what is the laminar flow. So this is about the viscosity. Now, as we know that there is a force of friction, so let us write an expression to show that force of friction depends upon what factors, or what mathematical expression we can actually calculate. So we see that let's say that these are the coaxial layers, cylindrical coaxial layer placed one above the another. Let's say this is close to the tube, this one is in center, so its velocity is v, that is maximum. Or you can say that this velocity is c, v. So here the layer which will be down will be having velocity v minus dv, and the one which is above will be having v plus dv, because we are moving from the, let's say from the wall of the tube towards the center. So we say that, like, this is offering a friction to this, resistance to this, and this is offering a resistance to this. But as we move from wall of tube to the center, the resistance is actually decreasing. Therefore, it is becoming less viscous and it has a high velocity. So on what factor the force of friction depends? Let's say that each layer has an area of a square centimeter. And what is dv? dv is the distance between two layers. dv is the distance between two layers, or sorry, dx is the distance between two layers, and dv is the velocity difference between two layers. dv is the velocity difference between two layers, the up and in another one, and dx is the distance between the two layers. So force of friction is directly proportional to the area of cross section into velocity difference between two layers divided by the distance between the two layers. So when we remove this proportionality sign, we put a constant which is called as, written as this, called as velocity, you can call it as coefficient of viscosity. Coefficient of viscosity, and the formula becomes this. And this symbol is called as eta. So it is force of friction is equal to velocity, coefficient of viscosity into A upon dV upon dx. So this is an expression in order to calculate the force of friction offered by one part of liquid to the another part. Now, what is the coefficient of viscosity? How we can define it? We can say that coefficient of viscosity is actually the force of friction. It is the force of friction. Like if you get a formula for this, just write a formula for this first. It is equal to F into dx upon A into dV. So we can actually define it. So we have, it is the force of friction which is required force of friction, you can say force of friction that exists between layers of area 1 centimeter square. Distance between them is 1 centimeter, and we can say that force of friction that exists between the layers of area 1 centimeter square, or you can say force of friction which is actually present between the two layers, and layers of area 1 centimeter square, distance 1 centimeter, and velocity difference what we need to maintain is the 1 centimeter per second. Or you can say force of friction which is required to maintain, this will be a correct one, force of friction which will be required to maintain velocity difference of 1 centimeter per second between the layers of area 1 centimeter square separated by distance 1 centimeter. And so this is what is the coefficient of viscosity, how you are going to define it. So it is the force of friction required to maintain velocity difference of 1 centimeter per second between the coaxial layers of area 1 centimeter square separated by distance 1 centimeter. So if we derive the unit for the viscosity, so it comes out to be F, we know that this relation we know, A into dV, putting the values, F we know is in dynes, dx let's say is in centimeter, area is centimeter square, and velocity is centimeter per second. Cutting this, we have dyne per centimeter square second. So this is actually the unit for the coefficient of viscosity, and you know that this quantity is equal to actually 1 poise. So the SI unit is poise, and 1 poise is equal to dyne per centimeter square second. So this is actually the unit for the viscosity. Now if we discuss about the factors on which the viscosity depends, so it depends upon nature of liquid, and again it depends upon temperature. So how it depends upon nature of liquid? If the intramolecular force of attraction is high between the molecules of liquid, then obviously it will not allow the layer to flow. So that means it is going to possess less velocity comparatively. Less velocity means more resistance. More resistance means more viscous. And likewise, if intramolecular forces are less, intramolecular forces less corresponds to the you can say less resistance. Less resistance means the less viscosity. Second is the temperature. So see, if you will increase the temperature, that means intramolecular forces will decrease. Intramolecular forces will decrease, so that means the resistance will also decrease and the substance will become less viscous. And the vice versa, that if you decrease the temperature, then force of attraction is going to increase. When force of attraction is going to increase, that means resistance increase, velocity decrease, and therefore the viscosity also increase. So this is how it depends upon two factors, that is nature of liquid and temperature. So I think you got it, that what actually this property of liquid is, that is viscosity, that is the resistance, reason is the laminar flow, and you have another definition also, and you can actually write an expression to show that on what factor the force of friction depends, and we know about the coefficient of viscosity as well, and the units also, the one that is the poise. And so this is the with this we finished with the properties of the liquids, that is the